Imagine a world where your smartphone, laptop, or any electronic device you use daily can simply dissolve and return to nature after its life cycle ends. This isn't science fiction. It's the incredible promise of biodegradable electronics. Welcome to our deep dive into how biodegradable electronics can dramatically reduce environmental impact. Make sure to hit that subscribe button, like this video, and tap the notification bell so you don't miss any future insights into groundbreaking technologies. Also, share your thoughts and opinions in the comments section below. Now, let's get started. The world is facing a mounting crisis with electronic waste. Each year, millions of tons of electronic waste, also known as I-waste, are generated globally. This waste contains harmful substances like lead, mercury, and cadmium, which can leak into the environment and pose serious health risks. According to the global e-waste monitor, the world generated 53.6 million metric tons of e-waste in 2019 alone, and this number is projected to reach 74.7 million metric tons by 2030. This staggering figure underscores the urgent need for sustainable solutions. Biodegradable electronics offer a compelling solution to this growing problem. Unlike traditional electronics that can linger in landfills for centuries, biodegradable electronics are designed to break down naturally through biological processes. This means that after serving their purpose, these devices can decompose into harmless substances like water, carbon dioxide, and biomass. Imagine your old smartphone becoming part of the soil, enriching it rather than polluting it. So, how do biodegradable electronics work? At their core, these devices are made from materials that can be broken down by microorganisms. Traditional electronics rely heavily on metals and plastics, which are not biodegradable. In contrast, biodegradable electronics use materials like cellulose, silk, and certain types of biodegradable polymer. These materials are engineered to maintain the functionality of traditional electronics while ensuring they can decompose safely. One of the most exciting developments in this field is the use of organic semiconductors. Traditional semiconductors are made from silicon, which is not biodegradable. Organic semiconductors, on the other hand, can be made from carbon-based molecules that are biodegradable. These semiconductors can be used in various electronic components, from transistors to sensors, enabling the creation of fully biodegradable devices. Consider the example of biodegradable sensors. These tiny devices can be used in a variety of applications, from monitoring environmental conditions to tracking health metrics in the medical field. After they have served their purpose, these sensors can naturally decompose, leaving no harmful residue behind. This is particularly beneficial in medical applications, where biodegradable sensors can be used for implantable devices that monitor vital signs and then safely dissolve in the body after their task is complete. Another fascinating application is in the realm of consumer electronics. Imagine a future where your smartphone, smartwatch, or even your laptop is made from biodegradable materials. This would not only reduce the environmental impact of these devices, but also alleviate the problem of electronic waste. Researchers are already making strides in this direction. For example, the team of scientists at Stanford University has developed a biodegradable transistor made from materials like cellulose and silk protein. This transistor can perform the same functions as a traditional silicon transistor, but can decompose naturally. The concept of biodegradable electronics is not just limited to small devices. Even larger electronic systems, such as solar panels, are being explored for their potential to be made biodegradable. Traditional solar panels contain materials like silicon and heavy metals, which can be harmful to the environment if not properly disposed of. Researchers are now developing biodegradable solar panels that use organic materials, which can harness solar energy efficiently while ensuring they do not pose environmental hazards at the end of their life cycle. Biodegradable electronics also hold promise in reducing the energy footprint of electronic manufacturing. Traditional electronic manufacturing processes are energy-intensive and generate significant amounts of waste. In contrast, the production of biodegradable electronics can be more sustainable. For instance, the use of organic materials often involves less energy, intensive processes, and these materials can be sourced from renewable resources. Let's delve deeper into the materials used in biodegradable electronics. One of the most common materials is cellulose, an organic compound found in the cell walls of plants. Cellulose is abundant, renewable, and biodegradable, making it an ideal material for electronic components. It can be used to create substrates, the base layer on which electronic circuits are built. Researchers have developed cellulose-based substrates that are flexible and durable, making them suitable for a wide range of electronic applications. Another promising material is silk. Silk is a natural protein fiber produced by silkworms and spiders. It is biodegradable, biocompatible, and has excellent mechanical properties. Silk can be used to create substrates, insulating layers, and even semiconductor layers in electronic devices. Researchers have developed silk-based transistors, sensors, and other electronic components that perform well and degrade naturally. Biodegradable polymers are also key players in this field. Polymers are long chains of molecules that can be engineered to have specific property. Biodegradable polymers such as polylactic acid, PLA, and polycaprolactone, SEAL, can be broken down by microorganisms into harmless substances. These polymers can be used to create various parts of electronic devices, from casings to circuitry. For example, researchers have developed biodegradable polymer-based batteries that can provide power for electronic devices and then safely decompose after use. Now, you might be wondering about the performance of biodegradable electronics compared to traditional electronics. After all, in the world of technology, performance is key. The good news is that researchers are making significant strides in this area. For instance, biodegradable transistors made from organic semiconductors have been shown to have comparable performance to silicon-based transistors. Similarly, biodegradable sensors and batteries are being developed to meet the performance standards required for practical application. One of the most interesting aspects of biodegradable electronics is their potential to revolutionize the way we think about electronic waste. Currently, the disposal of electronic devices is a major environmental challenge. Many devices end up in landfills, where they can release harmful substances into the environment. Even when devices are recycled, the process can be energy-intensive and not all materials can be recovered. Biodegradable electronics offer a way to reduce the burden of electronic waste by ensuring that devices can naturally decompose after use. Let's take a closer look at the environmental benefits of biodegradable electronics. First and foremost, they can significantly reduce the amount of electronic waste that ends up in landfills. This, in turn, can help reduce the release of harmful substances into the environment. For example, traditional electronics often contain lead, a toxic metal that can contaminate soil and water. Biodegradable electronics, on the other hand, can be designed to avoid the use of such harmful substances altogether. Moreover, biodegradable electronics can help reduce the carbon footprint of electronic devices. The production and disposal of traditional electronics contribute to greenhouse gas emissions, which are a major driver of climate change. By using biodegradable materials and more sustainable manufacturing processes, the overall carbon footprint of electronic devices can be reduced. This is particularly important as the demand for electronic devices continues to grow. Biodegradable electronics also hold potential for reducing resource consumption. Traditional electronics rely on finite resources like metals and fossil fuel. These resources are not only limited but also require energy-intensive processes to extract and refine. Biodegradable electronics, on the other hand, can be made from renewable resources like plants and biomaterials. This shift towards renewable resources can help conserve finite resources and reduce the environmental impact of resource extraction. Another important aspect to consider is the social impact of biodegradable electronics. The production and disposal of traditional electronics often involve hazardous processes that can pose health risks to workers and communities. For example, electronic waste recycling, especially in developing countries, can expose workers to toxic substances and unsafe working conditions. By reducing the need for hazardous materials and processes, biodegradable electronics can contribute to safer and more sustainable production and disposal practices, the development of biodegradable electronics is not without its challenges. One of the main challenges is ensuring that these devices can meet the performance standards required for practical application. While significant progress has been made, there is still work to be done to optimize the performance and reliability of biodegradable electronics. Researchers are continually exploring new materials and fabrication techniques to address these challenges and advance the field. Another challenge is the scalability of biodegradable electronics. Producing biodegradable devices on a large scale requires the development of new manufacturing processes and infrastructure. This includes sourcing renewable materials, developing biodegradable components, and ensuring quality control. Scaling up production also involves addressing economic considerations, such as cost and market demand. However, as technology advances and the demand for sustainable solutions grows, it is likely that these challenges will be overcome. Despite these challenges, the potential benefits of biodegradable electronics are too significant to ignore. They offer a sustainable solution to the growing problem of electronic waste, reduce the environmental impact of electronic devices, and contribute to more sustainable resource use. As research and development continue, we can expect to see more innovative and practical applications of biodegradable electronics in the near future. In conclusion, biodegradable electronics represent a promising and exciting development in the field of sustainable technology. They offer a way to reduce the environmental impact of electronic devices, address the growing problem of electronic waste, and promote more sustainable resource use. As we continue to explore and develop these technologies, we have the opportunity to create a more sustainable and environmentally friendly future. Thank you for joining us on this exploration of biodegradable electronics. If you found this video informative, please subscribe to our channel, like this video, and hit the notification bell so you won't miss any of our future content. We'd also love to hear your thoughts and opinions in the comment section below. Let's work together towards a greener future.